Up until now, we've been using the distributive property to multiply things out. Now, we would like to use the distributive property to work backwards. So what you've been doing so far is taking the terms that are on the outside or foiling, distributing through to get an answer. Now, our goal is to take the answer that we have and go back to what the original problem is. This is called factoring. Now, you've done factoring before. Simple factoring, such like, what are factors of 14? And you would say, well, 7 and 2, because 7 times 2 is 14. We're going to use that concept to factor out polynomials. Let's see how we do that. Factor this, 15w minus 13v. Now what I'm going to do with 15 is I'm going to break that down. I know that 15 is 5 times 3, and the w is there. And I also know that negative 3 is the same thing as saying negative 1 times 3v. What I am looking at is to find out what they have in common, and at most, what do they have in common. In the first term and the second term, what I see that they have in common the most is the number 3. Now the things that they have in common are what I get to factor out, or in other words, redistribute back out and put out front the parenthesis. The parts that I was not able to highlight in red is what I leave inside of the parentheses. So in that first term, I wasn't able to highlight a 5 and that w, so that stays inside my parentheses. I wasn't able to highlight the negative 1 and the v, so that will stay inside my parentheses there. Let's try another one. This time I got 3 terms. I look at each one separately. So I'm going to break 7u squared t squared down as 7 times 1 times u times t times t. 21 will be 7 times 3. Got the u and t times t for t squared. And the last one, negative u times t. Now I look at each term separately and see at most what do they have in common. The first 2 terms have 7s, but the last term doesn't have a 7, so I'm not able to highlight that 7. But I do see that each term at most has 1 letter u in common, and I also see that each term at most has 1 letter t in common. So I'm able to pull a u and a t out front, and what I have left over, anything that I was not able to highlight, stays inside of my parentheses. So I go back in 7 times 1 times u times t, so I get 7ut. I wasn't able to highlight the 7 or the 3, so I remultiply 7 times 3 to get 21, and that 1t that I don't have left over stays inside. Now, what happens when I factor out everything? Well, then you think, well, what do I have to multiply by to keep, or what number do I multiply by to keep it itself? And that's 1 or negative 1. So I have a negative 1 left over with that negative sign. So this is the factored form of 7u squared t squared plus 21u t squared minus ut. Now, what if you're not sure if you factored it correctly? Well, you could always redistribute back through to see if you get what you originally started with. And that's a great way to check your answer, just like we would check our answers when we started solving equations. Let's try another example. This is going to be more of the way that you would work it out. So I'll look at each term. I see that I can't break down 5c squared v any more than it's already broke down. I know that 5 goes into 15, so I'm going to go ahead and write the 5c squared, and I broke down the v squared as v times v. And then the last term, I went ahead again and wrote down 5c squared, and I broke out one of the v's from the v cubed and left out the v squared. And I did this because I'm already writing out what my greatest common factor is between all 3 terms. What each one of these has in common is a 5c squared v. And I can take that, factor it out. So what I have on the screen right now is what the common factor is. And each piece that I was not able to highlight is what remains inside my parentheses. So again, since I factored out everything from the first term, I have a 1 left over. In the second term, I have a negative 3 and a v left over. And in the last term, there is a v squared remaining. So this is the factored form for that problem. Applications. Penny is a fox terrier who who competes with her trainer in an agility course. Within this course, Penny must leap over a hurdle. This is the expression that models the height of that leap in inches after so many seconds, t. We're going to factor this expression, but then we're going to find out what her height is after a half a second. So here's the expression. I look at each term and I say, well, what goes into 20 and what goes into 16 at most? And also look at t and t squared. I see that at most a 4 and a t goes into both of those terms. So there's the common factor that I have highlighted. I'm going to factor that common factor out, and the 5 and the minus t is what's remaining, is what's going to stay inside my parentheses. So here's the factored form of the expression. Now we're going to move on to the last part of the question. It says, how high is Penny's leap after a half a second? So where I see the letter t, I'm going to substitute in that 0.5, and I'm going to go ahead and multiply it all out. 4 times 0.5, so that's asking what's half of 4, which is 2. 5 minus 0.5 is 4.5. 2 times 4.5 is 9. So after a half a second, the dog is 9 feet in the air. The next type of factoring that we're going to do is called factor by grouping. Now, the dead giveaway of grouping is that you're going to have 4 terms. If you have anything else, you're going to use a different type of factoring. So 4 terms, dead giveaway what grouping is. Now, how does grouping work? You group the first 2 terms together and you find their common factor. And you group the second 2 terms together to find their common factor. So let's look at the first group. 4QR and 8R. If I break apart their factors, you'll see that they have a 4R in common between just the 2 of them. So I'll factor 4R out. The Q and the plus 2 is what will remain in my parentheses. Now let's look at the second set of parentheses. 3Q and 6, their common factor is a 3. So the 3 is what I'm going to factor out between those 2 terms, a positive 3. And what remains inside the parentheses is, again, another Q plus 2. Now here's what's nice about the factor by grouping, is that when you do grouping, your first parenthesis that you get and your second parenthesis will always be the same. They will always match. So if you do the grouping and you see that they're not the same parenthesis, we've made a mistake and we need to go back in and fix that. Now I want to shift the paradigm here. Instead of looking at the parentheses, I want to look at the 4R and the plus 3. 4R is being multiplied by a parenthesis, and 3 is being multiplied by the exact same parenthesis. So what you can say is that 4R and 3 have a common factor of a Q plus 2. So I'm going to factor the Q plus 2 out. And when I factor something out, I only have to write it 1 time. So those go away. Now what I have left over is a 4R and a positive 3. I will group those together to make a second set of parentheses. So this is the factored form of the 4-term polynomial that I had above. Again, if you're not sure if you factored correctly, you can boil this back out and see if you got what you started with. So let's try another factor by grouping. Rn and 5n are what I'm going to group together, and I see that they both have an n in common. When I take the n out of there, I have an r plus 5 left over. Looking at the second 2 terms, they have negative r and minus 5. At most, the only thing that I could take out of there is a negative 1. And when I do that, I get r plus 5 from my second parentheses. Now, think if I distribute that negative 1 back through the parentheses. Negative 1 times the r will give me the negative r, and negative 1 times the positive 5 would go back to that negative 5 that I have there. So again, the n and the negative 1 both share a parenthesis that says r plus 5. So I'm going to factor that r plus 5 out. And what I have left over is the n minus 1, so I'm going to group those together to make my second parenthesis. So this is the factored form of Rn plus 5n minus r minus 5. And once again, if you're not sure if you factored it correctly, boil it back out. You should get Rn plus 5n minus r minus 5 back as your answer. Okay. 4ab squared plus 12b squared plus 7a plus 21. Again, I'm going to look at my first two terms. The greatest common factor between a 4ab squared and a 12b, 4 is the largest number that goes into the numbers. Each one of them shares a b squared, so I factor that out. What I have left over is a plus 3. Now, I touched on it earlier that I said when you do factor by grouping, your parentheses always have to match. So let's try it in a different way. Knowing that your parentheses have to match, I'm going to go ahead and write the a plus 3 off there. And I'm going to leave a gap there. And I'm going to ask myself this question instead. What would I have to multiply a by to get the 7a that's up in the original problem? You would say 7. Since you say that, then you know what goes in that particular spot. The 4b squared and the 7 both share a parentheses of a plus 3, so I factor the a plus 3 out. And then the 4b squared and the 7 get grouped together to make the final parentheses. So here's the factored form of that 4-term polynomial.